So, welcome to yet another episode of ENTECH Online. Today, we'll be talking the latest innovation in chemistry, and today's guest is Dr. Sunita Singh. She is Assistant Professor of Chemistry at Navyuk Kanya Mahavidyalay, University of Lucknow. She holds a PhD in Chemistry and Bioactivity of Essential Oils. Her work explores natural compounds and how they can help us to stay healthy. So Dr. Singh has published more than 35 research papers, and she has written chapters and edited books on volatile oils. She also reviews research for international journals and is an active member of the International Clinical Aromatherapy Network. I hope I said it right. And today we'll be discussing latest innovations in chemistry. So Dr. Sunita, what do you have for us?
Thank you, Dr. Deshmukh, for this wonderful introduction. And I think this topic is very relevant for the present scenario because chemistry is present in everything. From 11th class to till UG, PG, we study about chemistry in daily life. So
Right.
we can't imagine anything without chemistry. So discussing the relevant and recent innovations in chemistry is, I think, a very relevant as well as essential topic, especially for anyone who are directly or indirectly related with chemistry. Like it is
Correct.
not typically for a chemical or chemist person. Yeah.
So now even there is a chemistry in friendship and relationships. Chemistry is everywhere.
Yeah.
Okay. So what are the topics we'll be talking today?
Actually, as you have said, we are going to discuss the latest innovations in chemistry. I have categorized these innovations in three broader categories, and then we have sub-classified.
Then we go deep dive into it. Okay.
Yeah. Like I have divided it into building a sustainable future, where we are going to discuss the sustainable development part, like which innovations are going to carry forward our different challenges related to sustainable development or achieving our SDGs related to especially climate change and other we can say, because with chemistry there is always a I can say a negative point, like we get that's why the idea of green chemistry develops where
green chemistry. Okay, that's a buzzword today.
Yeah, because in green chemistry there is minimal use of solvents, or the solvents can be recycled for the purpose. So the wastage part has to be reduced is the main aim in green chemistry. And the second category, we are going to discuss the various innovations related to the engineering of different materials for the future of health system, where they are going to assist the future health system by different innovations, like we have nanozymes and chiral carbon dots. And the third category, we are going to discuss the different innovations revolutionizing material science and computational method. We are going to discuss AI-driven synthetic chemistry and single atomic catalysis and solid state batteries and 3D printing. These are some of the innovations. Yeah.
So mainly sustainability, we are talking about healthcare, and we are talking about AI in chemistry, right?
Yeah.
These are the three topics you said.
Yeah.
Okay.
Yeah.
Let's go on sustainability. So what's on your list now?
Okay, for sustainable part, we have recently listened a term that is metal organic frameworks, for which Osman Yagi with Richard Robson and Susumi Katigwa has received a Nobel Prize in chemistry. So it is not a very in the year 2025. And and this concept is not a newer one. It has been established in the year 1995. And the basic, if I have to say what this metal organic frameworks, it is a compound, or it is a material having a porous coordination polymers like structure, and they provide an extremely high surface area for different selective adsorption. Because
Okay.
in this we can change the porous size of the what type of thing we are going to capture. And
Mm-hmm.
this technology has a very bright future when it comes to capturing CO2, which is a very
Okay.
which is a very I can say a challenging thing for chemical related reactions, where this CO2 is come as a byproduct. And for capturing them, we have this metal organic framework as a very good alternative,
Mm-hmm.
where we can use this technology. And the
Mm-hmm.
best part is that we can modify the pore size accordingly, what type of thing we are going
Okay.
to capture. Yeah, so metal organic framework, the work is almost have,
Ongoing.
and yeah, ongoing. And it has a very good, we can say the practical applications include their capture of CO2 in from cement and power plants, and
Mm-hmm.
which are the main source of CO2
Emission.
uh, emissions. Yes,
Okay.
and yeah, and where there is a term what we generally use for seeing the how this going to be used. This technology is going to be used in future. We have a term, technology readiness level. This is TRL,
Technology readiness level.
readiness level. And for
Okay.
this MOF framework technology, we have a TRL value of 6 to 7, which is very good.
So
And
how is this scaled, ma'am? How is this scaled on 1 to 10? Is it
yeah, it is 1 to 10, and above 5, it is meant to be like it has a very good
good
future.
potential?
Good potential. So
Mm-hmm.
the market is expected to reach over $5 billion by 2030 when it comes
Mm-hmm.
to carbon capture and storage sector by this MOF method.
Okay.
So
So
yeah,
one quick
so
question on this. Sorry.
yeah,
Um, so this porous material captures the CO2 inside
yeah,
it, right? What happens to that? Where does the CO2 go? It is captured,
yeah, it
confined,
is capped.
and how do
Yeah,
you dispose it of?
yeah, we can use it. The captured CO2 can be stored in different equipments, and they
Okay.
can be utilized for some other methods. Because the main problem, while what we are using presently needs very high temperature and pressure equipments for capturing this CO2. So yeah,
Right.
this can be reutilized for different purpose.
So it releases again.
Yes.
Oh, okay. Okay. That's how
Okay.
you are doing recycling of that.
Yeah.
Okay. Is
And
my concept correct in terms of capturing,
yeah,
utilizing it somewhere, and
yeah,
then
yeah, almost, yeah, almost correct.
almost?
Yeah, yeah,
Okay.
yeah, yeah,
All right. So this is one innovation. What's the
yeah.
other thing?
The other thing is, I can say the plastic recycling. Because
Okay.
the traditional method what we are presently doing is just degrading the plastic. We are just
Correct.
so that plastic which are we are using currently for recycling purpose, what plastic we are getting is not a very good option for
Hmm.
plastic recyclization. So
Okay.
here also chemistry play a very vital role for plastic depolymerization. And the innovation involves the use of specialized enzymes and advanced chemical processes to break down these plastics into their monomers from where these plastics has been made. We are
Okay.
just back,
Okay.
yeah. So that monomers can be utilized in the way, because presently we are just used to remold these plastics, the
Yes.
traditional method.
Yes.
but
Yeah.
uh, but using these specialized enzymes and advanced chemical processes, we are just getting the fresh monomers from where we have started preparing the, like for polythene we have ethylene as a monomer. So we get
Right.
that ethylene, yeah. And various companies are also scaling this process for
Mm-hmm.
the industrial purpose. because plastic is one of the major challenge. Although,
It is a
like
major
in
pollutants today.
yeah,
Yeah.
yeah. Because in our earlier classes, we used to write an essay about science is a boon or a bane. So plastic
Yes,
is a
yes,
plastic is a living example of a boon as well as a bane.
as well as a pain.
So
Yeah.
yeah, yeah. So that's why chemistry has provided plastic. So now it's providing the
Solution also.
pathway, yeah, to
Yeah.
recycle this plastic in a, I can say, in a very healthier way,
Hmm.
because plastic pollution is one of the macroscopic problem, and through these specialized enzymes, we are providing a microscopic solution to it.
Okay.
Yeah.
What's the next one on the list?
Okay. For me, for next one, I will go to the health sector where because
Health
health
sector. Okay.
because yeah,
Before you jump in there, I have a question.
yeah,
Right. Though these innovations are forward looking and they will take care of the plastic waste in the future,
yeah.
what is your take on to the current plastic pollution which is there? Will it help somewhere, or it is for us to take care of it?
No, I think scientific community is finding the solutions for the current plastic problem.
Hmm.
There are some researches have been done where some microbial degradation was done on
Okay.
these plastic. Yeah, so
Hmm.
we are going back to our nature to have solution for this bigger problem.
Correct.
So I think yeah. So and but I can still say we are still going with the traditional method of recycling and degrading the plastic into a lower category plastic. So
Hmm.
presently, the problem is very big, but we are finding solutions as a
We
scientific
are finding
community.
solutions.
Yeah, yeah.
Okay.
So
Yeah.
health,
So let's jump into healthcare. Sorry for
yeah, yeah.
interrupting
No,
you.
no, no
Let's
problem,
jump
no problem.
into healthcare. Yeah.
Yeah, healthcare, because we know health is wealth, and we are totally dependent upon the chemistry for or the synthetic chemistry for the drug discovery and everything. But
Hmm.
as we know, we have different, I can say, side effects associated with this chemical part. So
Yes.
we are finding solutions for this for drug development, or for, I can say, like I have used the term nanozymes with you, because
Nanozymes.
nanozymes,
Can you explain it
it
a
is a
little bit on that?
yeah, yeah, it is a
Nanozymes.
combination of nanotechnology and enzymes,
Okay.
because
Okay.
yeah,
Okay.
so we
Hmm.
get a term nanozymes because in recent years we have seen that nanotechnology comes as a very bigger area of
Yes.
research for either it is for a synthetic part or for the we can say drug discovery part. And
Hmm.
we have seen nanozymes because in our natural biological system we have enzymes in our body, which are if we go chemically they are proteins, but they have
Yeah.
some, yeah, but they have some issues like we know that protein has a tendency of denaturation at a particular temperature. They are very fragile in nature. So these type of problems can be overcome using these nanoenzymes, where
Hmm.
we have not such issues like denaturation at temperature, and there is a short lifespan of these proteins when it comes to some type of delivery in drug discovery. So these nanozymes can be, uh, uh, we can say, can be a good alternative for our natural biological system. And they can include the creation of low cost biosensors for point of care testing, targeted anti cancer therapy. So we get more precise system for whole when it comes to medical treatment.
Okay. So this
Yeah,
is for discovering the molecule of a drug, or it is a drug delivery system to the human body.
it is more about drug delivery system.
It's a drug delivery system.
Yeah,
Okay.
yeah,
I
and the
okay.
yeah, and the base. I would also like to mention, like what we are discussing about different innovations. The main challenges is like we have done sufficient in the lab. Uh, like
Okay.
results are good at the lab level, but the
Hmm.
scaling of these all innovations at a larger scale is still in very initial stage. So, or whether it is nanozyme or whether it is plastic recycling, all these needs we need a time, we need a proper time to get to get the proper results or to see the results. It takes time. Yeah.
So when do you think this technology will be ready for use?
It has potential to grow in multi-billionaire market in especially in diagnostic and therapeutic field. But yeah, I think around 2030 or uh, uh, after that, we
Mhm.
will get to see these
So we need
nanozymes.
to wait for another 5 to 7 years to
Yeah,
get
yeah,
it
yeah.
available for common use.
Yeah. Although,
Okay.
like nanotechnology is getting in every field, like
Yeah.
either it is in synthetic part or it is in drug delivery system, we are utilizing this nanotechnology. Uh,
Mhm.
but the final results or the results which are can be used for the society needs time.
Okay.
Second
So what?
one in yeah.
This is again in the health system. Next one.
Yeah, yeah. It is
Okay.
about the chiral carbon dot system. We
Okay.
have learned about
If you can
chirality.
explain the concept behind it, so that
Yeah, yeah,
our young audience
yeah,
will know about it. Yeah.
yeah, yeah. Like in chemistry, in 11th class, when we have an introduction about stereochemistry, we use a term chiral carbon. So
Okay.
chiral carbon means a carbon having four different groups attached to it, and they have one non-superimposable mirror images. So
Hmm.
by these chiral carbon dots and these biosensors, we have an option to utilize particular, I can say, particular type for the particular purpose. Like when it comes to health system or anything, like we have, I have a compound A,
Hmm.
and we have there two isomers A and B,
Okay.
having both have chiral carbons, so they can be utilized for different purposes. So
Okay.
the separation can be done using these techniques, and biosensors are formed using nanochain method or the nanotechnology, what we call nanochain biosensors.
Okay.
So yeah, so these innovations involves luminescent nanomaterials and self-assembling nanostructures for highly sensitive molecular detection. Because
Okay.
in this present scenario, detection of a disease is a very big challenge.
Hmm.
For yeah,
Yes.
because because nowadays when we visit to a doctor, they just provide a list of different tests before
Hmm.
diagnosing anything. So the typical identification of that disease was very important. So
So
in
how
this,
will this innovation change the healthcare?
like these biosensors or these chiral carbon dots can be utilized to develop ultra sensitive detection of disease biomarkers. Like
Okay. Okay. Okay.
if we have a particular biomarker, maybe they can react with only one chiral part, not the second one. So through these chiral dots or biosensors, we can detect the disease more, I can say more easily and more
Accurately.
accurately. Yeah.
Okay. Okay. So when is this going to be available, ma'am?
Uh, most of the innovations are going to be available, or I can say have a we can say visible result after 2030, and it is also like for chiral carbon dots and nanochain biosensors, the market is around $120 billion, and they are more specified with the diagnostic part. Yeah, the
Diagnostic part.
diagnostic treatment where these chiral carbon dots and nanochain biosensors can be utilized. Yeah,
Okay.
yeah.
So what is the readiness level for this? 2030, you
Uh,
said.
Yeah, 2030, but the readiness level is in the range of 4 to 5, because as I have said, the basic challenge is like these all results are at the lab
Lab
level.
level.
Yeah. So
Okay.
going to the scaling up the whole process needs time, as well as different tests, and we need proper evidence, like with
Evidence.
like
Yeah.
yeah, because like with we know very much thing about Ayurveda and everything, but still we
Mm.
have so many doubts about Ayurveda because the clinical evidences are very less.
Mm.
Uh,
Okay.
so yeah,
So evidence-based, progress which we'll have to monitor.
yeah.
Okay. So what's next on the list, ma'am?
Yeah, for next on the list, I have the different materials that are revolutionizing the material science and computation.
So this is a
Uh,
different category altogether,
yeah,
materials.
yeah, yeah. It's a
Okay.
different category where
Mm.
I'm going to discuss about solid state batteries and a single atomic atom catalyst and AI driven chemistry, or I can say AI
Okay.
driven synthetic chemistry. So we
So let's
all know
talk about
about,
batteries. Let's
yeah,
talk about
battery.
batteries. Yeah.
Yeah,
Okay.
we all know about lithium ion batteries
Yes.
and the, yeah, but currently what we are using, and the basic challenge is about these lithium ion batteries is the safety part and the energy density.
Mm.
The electrolyte what we are using currently is in the liquid state.
Mm.
So
Okay.
there is a chance these lithium ions are going to react with these electrolytes, and they form different particles or materials that are known as dendrimers. So they just
Okay.
yeah, so they just I can say they just divert the energy part in different. Don't have a specific route of lithium ions to only generate energy. They just divide into different parts using reacting with these liquid electrolytes.
Okay.
So that's why we have utilizes this solid state as an electrolyte
Okay.
to compensate this loss of energy as well as safety portion, because we generally listen about there is a explosion in batteries of
Yes.
phones and
Yes.
everything where we have
Yeah.
lithium ion. So the basic reason behind this is the use of liquid electrolytes in these batteries. So these
Okay.
solid state batteries are going to play, and these solid state batteries in the form of ceramic and polymers uh, are uh, going to compensate this safety issue as well as the energy density issue.
Okay.
And yeah, and they provide the stable option, and the technology readiness level for this solid state batteries is 7 to 8. And we are
7 to 8.
going to
That's quite
see, yeah,
advanced.
yeah, we are going to see this their application part in electric vehicles also. So yeah, this solid state batteries is going to have a very, I can say, brighter future in the near year. Like, yeah,
So one quick question here, ma'am.
yeah,
Is
yeah.
the sodium ion battery a part of this particular cycle or it is something different?
It is different. We are
Okay.
we are mainly focusing on the lithium ion batteries because they
Okay.
are widely used in different applications. So I
Okay.
think, yeah.
Okay. Yeah. Let's move on.
Uh,
What is the next
yeah.
on your list, ma'am?
Next one is the single atomic atom catalysis, and this innovation is the advanced engineering of catalyst where every single atom is individually dispersed and stabilized to function as an active site. Because I can say, like in any synthetic part or in any synthesis, the specification and the target, like what we want to get, is main priority. And having a particular atom which are we know which are going to provide such product, or
Mm-hmm.
we can say in a controlled release of an atom to have a desired product, is I can because in chemistry, what I have told about green chemistry, uh, we are in green chemistry, it is emphasized like we have to opt that path or that chemical process where we get less of the byproducts,
Okay. Hmm.
because utilization or recycling of byproduct is also one of the main challenge.
Correct.
Like when we prepare soap, we have a byproduct like glycerol in a very good amount, although
Yeah.
glycerol can be used in various purposes, but
Mm.
in many chemical reactions we don't have a, desired byproducts, so we have to, or either we have to dispose of these byproducts. So single atom catalysis can be a game changer for a can be a game changer or a very good option for we can say a targeted chemical synthesis.
Okay. So
Yeah.
outcome would be what? A complete utilization of the byproduct, or it will create a byproduct of a particular nature only. What is the outcome?
It will provide the, I can say the second option,
Hmm.
what you have mentioned. And as we know, the main purpose of a catalyst is we can say to make the process fast without utilizing in that particular reaction. So these single atom catalysis can be provide maximally efficient catalyst for if we go to the application part, they can be
Right.
utilized for fuel cells and electrolyzers and enable the low temperature conversion of methane is one of the
Okay.
application part what we can see.
Okay.
But when it comes to their technology readiness level for this technology is around 4 to 5, and
Okay.
yeah,
Okay.
but we can see a wider use in petrochemical industries in the near future. Yeah.
Okay.
Yeah.
So this was in the category of materials. Okay.
Materials, yeah.
Okay.
One more technology what we are also listen about, we have 3D printing materials, or we can say advanced additive manufacturing materials, in which
Yeah.
in which there is a development of specialized chemical building blocks, involve photosensitive resins, ceramics, and high performance polymers for high
Hmm.
resolution 3D printing. And the basic use, if we come to these 3D printing, is in the medical field, and in aerospace components,
Hmm.
and in various chemical reactors. Yeah.
So these are kind of composite material or something like that, or
Yeah. Yeah. Composite materials they are. And I
okay.
think I have forgotten one, uh, I can say technology which comes in the sustainable part, which is the
Hmm.
revival of electrochemistry. uh, because we have listened about synthetic electrochemistry, but the basic purpose of this electrochemistry is to replace the thermal uh, processes by this electricity. We going to use electricity for different chemical reaction. What is the basic definition of a chemical when it comes to electrochemical reactions, where we utilize electric current for the particular chemical reaction? like
Right.
for like for I would like to cite an example of ammonia synthesis or manufacture of ammonia using
Hmm.
Haber-Bosch process, which is a very traditional method. Along
Hmm.
with there is a one, I can say, disadvantage, having a lots of carbon emission. So using renewable electricity to make this ammonia and valorize the CO2 capture is a very sustainable method for utilizing this technology for producing ammonia as well as valorizing the CO2, which is a byproduct of this method.
So you combine both these two to give you a better
Yeah.
sustainable outcome, I will say.
Yeah, yeah,
Okay.
and the last one in the category of this this composite material or the computational method is the AI-driven chemistry,
Okay.
AI-driven synthetic chemistry, where we are using this artificial intelligence and machine learning for a very targeted as well as accurate prediction as well as process method and to get a proper automation of that whole process
Okay.
because yeah, because this AI provides a very we can say it makes our work very easy as well as just eliminate the I can say the side reactions and provide us to focus on the correct reactions and to proceed further. Although we use computational method in
Chemistry.
currently
Yeah.
we are also
Yeah.
using, but AI provides the precision also along with this computational method. So yeah, the coming years, AI-driven chemistry is not a very new thing for us because we are using AI in different
Different fields.
area. Yeah, so AI is just not making everything easy, but at least it is providing us to go to the right path without wasting our energy in different side reactions, or we can say side ways that are interfering with the main product. Yeah,
Yeah, it will make it more efficient. Yeah.
yeah,
Agree.
yeah,
Okay.
yeah.
And what else you have?
What else I have? I think I have discussed most of these
Most of these. Okay.
innovations
Mm-hmm.
and I can say like with everything we are advancing in our technology, so with chemistry also without involving these AI driven chemistry or new technologies with the traditional chemistry, we are not going to get proper results as well as to be sustained in this whole environment what we are facing. We have to I can say the right word is we have to modify our level of thinking towards this thing, like we have to inculcate the AI process also.
Mm-hmm.
We have to go to the nature for like plastic recycling. We are most focusing on the chemical part. We are not
Okay.
utilizing or we are not exploring the biological part, or do we
Mm.
have different microorganisms that can degrade these plastics, because plastic is one of the biggest challenge I can say in
Correct.
present scenario.
Mm.
So I think I have give a glimpse, although many other uh, I can say many other innovations are also there, but these innovations
These
are
are
going
major
to
ones.
yeah, these are major ones, and we are going to see their effect in up in coming 5 to 10 years. So I think this is the right time to discuss these innovations. So
Correct.
we have like metal organic frameworks, we all know, but after getting Nobel Prize for this, people
Mm.
are
It
more
came into the
curious.
limelight.
Yeah,
Yeah,
people
yeah,
are
yeah,
more
true.
curious about this.
Mm.
What is metal organic frameworks? Because I have seen many papers which are published on this topic. So people are doing work. I think I can say in the correct way, in the correct path, and we will get good results in coming
In
years.
these
Yeah,
areas. So
yeah,
just quickly to summarize, right? So we saw
yeah,
the innovations in the area of sustainability, one category. Two was healthcare, specifically drug delivery system.
yeah,
And third, which was your materials. I think these are the
yeah,
three major areas and some innovations into these three categories, correct? Now,
yeah,
I know that these uh, innovations will come to, I will say, production use or can be available to common people or industry in next 5 to 10 years, looks like, right?
yeah,
So it is a good horizon for our listeners who are young students and also the researchers that focus on to these areas or research areas where you can see a bright future into this. So those who are interested in these areas or particularly in chemistry per se, what will be your advice to students and researchers?
Yeah, I will suggest them to, I will say like they have to stick on basic chemistry part, but
Okay.
apart from basic chemistry, they should learn something which are going to play a very vital role when it comes to synthetic chemistry, or we can say when we want to use in medicinal chemistry. So I
Hmm.
think they should know some type of programs, or I can say they should know the applications of AI
Okay.
in these research areas. Like, yeah, because in upcoming years we are going to see more about this AI, even in research also. Because currently we we are more know about the AI for writing papers, but
Correct.
yeah, but for yeah,
Okay.
but maybe in coming years, people are going to see the AI as a game changer when it comes to utilizing it for different organic synthesis, or to get a prediction of different paths which are going to provide a particular product. So I think
Hmm.
they should, if they want to do such type of research, they should learn some programs like different they have knowledge about some softwares also, which are
Okay.
going to yeah, which are going to be important in these areas. So I think they have to update themselves, because the traditional method they are not going to get much more. So they
Hmm.
have to update themselves along with the traditional one,
Along
I
with the
can say.
traditional
Yeah,
one. Okay.
yeah,
So that is a great advice. So have your basics
yeah,
absolutely foundationally clear, do
yeah,
some research, but get computational methods, AI, ML, and other advanced techniques to
yeah,
complement your research, right?
yes,
So
yes,
that's the advice, and that
yes.
was the end of our podcast. So thank you very much, Dr. Sunita. See you again. Thank you.
Thank you. Thank you so much. And I would like to mention, like, you have summarized my whole points in a very good way. And I think, yeah, because sometimes,
Thank you.
because because the first listener for me is you. So if
Yes,
you get my points, I think our listener is going to understand what I want to say.
absolutely.
And
That's a
yeah,
great compliment from your side. Thank you.
thank you so much. Thank you
Thank
so
you.
much. Thank you.